back to our best practices videos. My name is Stephanie Bowen, and today we're going to be talking about problem solving using the 4 operations. There are many ways that we can engage students in problem solving. The example that we see here is a 3-act task. It starts by watching a video. We can see that a jar is being filled up with candies, or in this case with Whoppers, and then we would engage students by asking them, how many Whoppers are in the jar? Each student, no matter their mathematical abilities, can participate in this conversation. We encourage students to think, what is the lowest estimate and what is the highest estimate? And now they're wondering, how many Whoppers are in the jar? For Act 2, we want students to ask questions. What other information do you need to answer the question? For example, students will ask, how many Whoppers are in a bag? Because we saw some number of bags going in, and we can provide that information. Even just counting this number of Whoppers is a problem solving. Some students can use multiplication and then addition, repeated addition. There are lots of ways to engage students in the problem solving as they're asking these questions. Students will ask how many Whopper packages were used? How many went into that jar? It went on fast forward. So here it shows them the number of bags that were used and how many from the last bag didn't fit. And then we would move on to asking our kids again, okay, how many Whoppers fit in the jar? You can see that this is a very engaging way to get kids involved in problem solving using multiple operations. Once students think they have the answer, then we show the video telling students exactly how many are in the jar. In this problem-solving unit, students will be solving both 1- and 2-step problems involving any of the 4 operations. In order to make sense of these problems, students will be using objects, picture models like arrays, area models, number lines, and tape diagrams. From their models then, they will want to write equations and then be able to solve, possibly using an algorithm. Notice that addition and subtraction problems include numbers within 1,000, and multiplication and division problems will include single-digit factors and products less than 144. We want to focus on understanding the context of the problem in order to solve. This is an important part of the benchmark and is specifically mentioned in the clarifications. What will problem solving look like in the classroom? We want to see students reading and engage in real-world problem solving and modeling with manipulatives, then using the model to create an equation. You might see students using base 10 blocks like in these examples or other manipulatives. In this 2-step problem, we see multiplication and subtraction, and we can see the 2 steps clearly in the equations. We might also see students writing their own story problems. In this 3rd example, we can see a 2-step problem being modeled with color tiles. And again, the equation is also being written to connect to the model. What will student learning sound like in the classroom? Here are some great questions to help students focus on the context of the problem. We want them to be thinking about what is happening in the problem, what they need to find out, and when they are writing their equation, what those numbers represent from the problem. We can also ask questions that help students see that there are different ways to problem solve, and also focusing on that unknown using a letter in the equation. These questions will help students focus on MTR 2 and 7. Here is a list of vocabulary words that students and teachers should be using during their mathematical discussions. It's also provided to parents in the parent letter in STEMscopes. Here are some examples of how students could demonstrate their knowledge. This is an explore from the STEMscopes where students are problem solving, creating a model, and writing equations to match. This is an example of another explore where students would be problem solving in groups and creating their own models and equations. Again, student work will vary based on how they want to model the problem, but that's a great part of the conversation we want to be having with students. This example comes from a Show What You Know out of the STEMscopes, and there are also games where students can be matching equations with models. As you're visiting classrooms and asking students questions, we want to focus on understanding the context of the problem. Here we have a sample problem and then 4 possible questions that students could be asked about that problem. For example, explain how your model represents the problem, or what equation could represent this problem. Here's an at-home activity. It's called Describe and Go from the parent letter in STEMscopes. In this activity, parents simply choose a task that they do regularly with their child and then come up with a multiplication or division situation to go along with it. For example, we will bake 24 cookies. If I give the same number of cookies to each of 4 friends, how many will each friend get? This connects to MTR7, applying mathematics to real-world connections. Thank you for joining us for this best practices video focused on problem solving. We'll see you for the next one.